Hi, today I'm going to try to do something that's probably very interesting. So let me set up the background. Earlier today, I was thinking about file system APIs in context of Swift, and I look around for the existing libraries out there, and I've started, down the path of looking at PathKit, which I have been using indirectly via dependencies. Uh, but so I encountered this project, um, and I noticed that it's failing. Its continuous integration is failing. So I was like, oh, what's going on? This is a nice project. A lot of people depends on it. So I looked into its history, and apparently this has been happening for a while, at least since August, right? So let's look at what's happening here. Um, well, there are two configurations, and the tests on Linux are passing, but on OS 10 it's not. So let's look at the build log here, and this is a very nice log, and we can see that, okay, one of the tests that's named, there's something is being tested that's last component without extension is failing, right? So I cloned the project. You can see I was looking at it earlier. So I cloned it. You can see I cloned it from the original repository, and I ran the test on my Mac. And no doubt we got the same failure, right? So it's at PathKit spec line 213. So let's look at that. PathKit spec 213 is testing something. It's creating this path object with this specific path, and then it's like last component without extension. So last component presumably is the thing that's after the last slash without extension. So this two dots is in Unix two dots means the parent repository, right? So if I go to sources and two dots above, that means like the current repository, because that's the parent of sources. So um, so we're getting the last component, which is the two dots, which represents the parent component, parent directory, without extension, and the text is expecting it to be a dot. This is kind of curious. So let's look at curious to me, because does it make sense that one of the two dots that represents parent uh, directory is considered part of a file extension? That's not okay. So let's look at it. PathKit.swift, and we're looking at last component without extensions, right? Last component without extension right here. Okay. Oh no, that's not it. PathKit.swift, right? Last component without. Okay, so the implementation is here, and it's creating an NS string and calling deleting path extension. Okay. Oh yeah, the things to notice here is there's a note, and it says it returns a single dot for two dots. So this is definitely something that has been noted by the author. Okay, so there's obviously a discrepancy here when we and one way is considered correct by Kyle, the author of this library. But if we look at the implementation, it's simply forwarding a method from a string, right? So from foundation. And what it's doing is it's creating a string from last component, which is the whole component which is NS string forwarding to the last forwarded the last pass component method. All right. So basically, what's happening? Let me demonstrate in a playground on Mac OS, is that we have a NS string, and we are testing. The test goes like this: we create a NS string from this path, this Swift string, right? And then first we call last path component. Well, I guess we are going to import foundation. Okay. Yeah, I wanted to equal here. And then we call last path component. All right, so this should give us the two dots because that's the last, if you have multiple slashes, that's the last part. Okay, that's expected. All right, then we come here, we're passing this value to deleting past extension, right? So that means I'm gonna create another wrapper for NS string and call deleting past extension. Again, this value is the two dots. And you can see that on OS 10, I think this API does what I expected. Since it's two dots, it's representing the parent directory. Where when we call deleting past extension on the parent directory, it doesn't do anything. It doesn't consider the last dot as the dot in the extension file extension name, right? So this is a behavior that's different from what's being noted here and what's being tested in the spec, right? Right. So in the spec, 213, I remember. In the spec, we expect that to be one dot, which is very, very curious. So since OS 10 test is failing, which we have verified, it should be failing. That must means it's succeeding. The test is succeeding on Linux, right? So here's my Linux app. It's just the Ubuntu image on VirtualBox. I've already opened Swift. So let's try that out. I'm gonna import foundation. Okay, and we're just gonna go straight to creating an NS string. And let's just give it the parent directory. And let's call deleting past extension here. And sure enough, we got one dot, right? Even though it doesn't make much sense in this context because double dots shouldn't be considered a path extension. So here, we can argue about which one is correct. In my intuition, the OS 10 behavior is correct. And since OS 10 foundation is older and has been used more widely, and it's probably thought about and iterated more, and also it's a precedence. So I'm gonna call that this Linux implementation is wrong. Okay, so that is a very long way to say that there's something to be fixed here. And this is what this video is about. I'm going to try to fix the foundation implementation. Okay, so yeah, let's do it. First, I'm gonna leave the world of PathKit, and I have cloned the Xcode the Swift projects before, so I'm just go there, and as you can see, I have the Swift various open source Swift repositories here, and the first thing I usually do is, especially after having haven't not having worked on this for a while is I call use this update checkout script inside the Swift utility folder to update every repository to make sure they're in sync. I ran this earlier today, so this should be relatively quick. Oh, we did get some changes. Great. Okay. And the next step is just going to Colib Foundation. Make sure I did make any change. You know what? That makes me want to update it again because there's a chance I didn't check out successfully. Okay. So this is a repository hosted on GitHub under Apple's account, and it's the foundation implementation used on Linux. I say it's used on Linux because if you look carefully, well, let's just look at one of the tests being run. By looking at this, you can tell like it doesn't even run tests on OS X, right? But the page we were on earlier tells us we can develop. This is under getting started.md. We can develop it under OS X. And usually when I start working on a project like this that I don't have intimate familiar knowledge, I'd like to establish a baseline before I get to it. So we're on master. We're on master of this repository, and presumably there's a way to run tests. So we need to run this test. Okay, all right, let's do it. I'll explain it when we're running the test. So I'm opening up the workspace hosted inside this repository, and I'm selecting the test foundation target and hit Command R, right? So what I'm doing is basically running all the tests before I start working on this project. That way, if you know, I know that what's the current state of the project is. If something is broken and we make a change, we need to make sure the change didn't make it more broken, right? If it's, for example, there's of all tests passes, then when we make a change or when we add a test failure, a test case that we expect it to be to fail, we know that we caused it as opposed to, you know, whatever is going on with the current project. So when I run Command R, I think we'll build a bunch of stuff. It doesn't matter what it is, but then we'll start running tests, and the result of running tests is going to be here. And I think, if I remember correctly, not all tests pass on OS X, which is, you know, not great, but it doesn't affect anybody because nobody is really using this library on OS X except maybe a super minority of enthusiasts. Yeah, but you know, we'll see how many tests are failing, and then we'll start making changes to the project. And hopefully, when we do, we will start seeing. You know, the goal is after everything, we would see the same. So, for example, okay, we've executed 1,000 something tests, and 16 are failing. That's okay. We don't care about. We may care about which ones are failing, right? But that's okay. We need to make sure that after we make our changes, this number doesn't change, right? Or if it changes, if less tests are failing, we need to figure out why. Or more tests are failing, we need to figure out why as well, right? So okay, 16. We need to remember that number and come back to it. Okay. So remember the thing we're trying to fix is something called deleting path extension, right? So in all the occurrences of this string in the project, there's some are in the test foundation target. So looks like there is a test for specific for it, right? And then here's another occurrence of it that is a computed property, which is a URL, but we're dealing with string. So here is something that's marked unavailable. Here's another URL one, but here is the one that returns string. So this must be the one we need to look at. Okay, so we know that for sure it's in NSPath utilities file. And then I'm also going to look at the test here. So for the test, let's go back. Okay, so we're creating a bunch of strings from path strings, and then here are the expected value after we're calling the deleting path extension, right? The result here. So basically, we're looking through this array and make sure that the result is what we expected, which is the second, the value in the dictionary. Okay, great. I guess maybe a good way to start this project is to add our own test case here. So yeah, let's add it. Our test case is A and then 2 dots, right? And I'm going to say that I expect the result of that to be deleting path component. Oh, actually, we don't even care about the A, right? That's the after the last component something something. It's just 2 dots. So I'm gonna say deleting last path extension doesn't make much sense for this value because it actually represents parent directory on Unix, which is also the case on OS 10, right? Okay, so now I've added a test case, and we know that it's not the current behavior. It's the outcome we want for this change. So if I run the test again, I guess I can start running it. We'll expect, we'll build the project again and then run all the tests. And remember from previous tests, we have 16 failures. And now we should have 17 failures, right? Because this test, if nothing, well, let's investigate. Deleting path extension. Deleting path extension. So this test was previously passing, right? Passed with 0 seconds, all right? And we're running the new batch of tests. And let's see if that test. Okay, great. So we can already see that this test now is failing, and it's kind of beautiful because it's the reverse of the testing, the fail reason on the PathKit test, right? So we're expecting 2 dots and we're getting 1 dots. Well, we already saw once where the implementation of deleting path extension is, right? It's in NSPath utilities. So let's just do that in Xcode. It's in NSPath utilities. So, all right. Okay, this is the implementation. Let's look at what's inside and what can we do to fix that test. So it started by calling something and then return fixed self and then handling some special case. But as you can see that at this point, we grab a property named start of path extension, and then, well, I don't know why there's a parentheses here. I'm going to delete it. And then we create a string. We basically say prefix up to the index before the extension position. That makes sense, right? So that tells me that if I'm going like abc.swift, the start of path extension is probably like here, and then the prefix, I'm taking self prefix, so this part basically chopping off the rest, right? Let's look at how the start of path extension is found, because what we're expecting is that if the input is like this, we shouldn't try to do this, right? So this guy should give us nil so that we go to this branch. Or if that's not the proper place to handle that, then at least we need to special case it there as well. Fixed self. Fixed self is a string. Maybe we can just special case the fix here. Let me play with the OS 10 implementation again. So when we have, well, I'll just do it here. So obviously when we have two dots, we want two dots, right? But if we have two dots and some other file, interesting. So this is actually considered a file name, and the last part is a extension, which kind of makes sense. I think Unix probably does the same thing. If it's one dot, we'll keep the one dot, and I'm expecting the Linux implementation to do the same thing. Swift with magic parameters. Again, this is not trunk, obviously, but hopefully the behavior didn't change that much. So if we supply two dots and say deleting path extension, we get one dot, which we want to fix. But if I say two dots with some other stuff, then we chop off the string, okay? But if it's just one dot, it's one dot. I'm guessing that is what this is about, right? If the length is smaller or equal to 1, let's see if it's the length is 0. Yeah, I'm also expecting this behavior, which is like if we give it this guy, we'll get the dot because this is being quote unquote fixed by this guy. All right. Okay, so looks like there's a logic that finds the start of path extension. Let's look at it. Maybe it's inside it's a proper place to do other logic. So first we start with precondition, and then we get, okay, this is extension of string. Okay. All right, so we're a string. Interesting. That means this is redundant, but let's not get distracted. So we get a cursor position, which start from the end of the string, and we have a start of last path component. Probably is like the file name with no slashes in between before it, and then we basically go from the end towards the beginning like this. We start from the last position and go to the beginning. If this is the string, we grab the index before the cursor's position. So we start from here, we look at here, we get the character at this position. If it's a slash, then we bail. Okay. If it's a dot, so if this is a dot, for example, and this is the last component, well, let's say this thing is the last component. If this is if it's a dot, and that's the last position, last component's previous position. Okay, so if the last position start with a dot, right? If this is the last position, then we don't chop it off, right? So that's just a dot file. Yeah, so if it's like something like this, we don't chop, we don't consider that's the beginning of the extension. Instead, we return nil, so we don't chop off anything. Okay. So it looks like when we encounter this dot, that's when we start considering whether we need to return whether there is a path extension. Nil means there's no path extension here, obviously. So we need to basically need to add one more condition inside this block, and that condition will return nil, right? Okay, so we need to make sure that the start of the last component has a distance of 2 to the end index. And then we need to make sure the contents, both contents are 2 dots. Okay. So we're going to add in one more condition here and see if it makes sense to merge it with the previous one. So we've seen a dot, and I'm going to say if the previous position is index before end index, right? So that means we just moved one forward. Let's gonna get rid of this change. And index before the previous index is the last component start position. And the character at this position, index before the previous position, right? Previous position. Index before previous position. If that character happened to also be a dot, then this is time to return nil. Oh, return nil. Okay, so the editor is happy about it. I'm going to try to compile. We compiled. We're running tests. And the test, again, is about this one, so I'm going to keep looking for it. I think there's probably a nicer way to write that logic, but we'll figure it out later. Okay, so we have 16 total failures again, instead of 17. No, that's not the end. Okay, here it is. We have 16 failures instead of 17. Deleting path extension. Okay, that test is passing again. Great. What is the most efficient arrangement here? I can abstract this value instead of taking it out twice, repeating it here. Okay, so I'm just gonna say case let preposition be this, and then now we can use that variable preposition preposition. All right, so that should be the equivalent logic. Cool. Okay, let's see, review the changes we've made. Okay, so this is the long ass logic we added. I don't think there's a column limit in Colib's foundation, so that's probably okay. We can use an OR to connect them here, but this is the equivalent after the compiler is done with this logic anyways, I think. So we don't want to check in this for sure, and we do want to check in the test, right? So, okay, let's add this a little bit by bit. I'm gonna split this guy to remove plus lines, delete them. Okay, and this guy. So now our patch includes this change, and the test. Okay. Make a new branch, inconsistency. How about that? Fix, so it makes sense to align Linux Foundation's behavior to that of Mac OS. Okay, that's a pretty good commit message. I can get rid of this now. Now, we have made the code change for open source foundation. Now, are we ready to make a pull request? I think we can do something better. First of all, let me make sure I can push it. Okay, I do have a fork of this repository, so let's push my branch to my own fork. All right, great. This probably will take a while because the delta between the last time I updated the repository and now is all going to be pushed. Yeah, look. Anyways, so we have the code. I can go to my repository, my fork, and say new pull request. I can pick my branch here. Yeah, that looks right. Okay, so I can choose to make my pull request now, but I think a better thing to do is to give Jira some love. So in case you don't know, Swift has an open bug tracker. I'm going to first see if any mentions of deleting path extension exist. Deleting path extension. Okay, it doesn't exist. So I'm going to start file a bug, and then we can assign the bug to ourselves, right? So inconsistency behavior Mac OS versus Linux. So filing bug itself is a form of contribution. So even if you don't have the knowledge or experience to do what I did previously, this part is still very, very valuable. and the Swift team is actually doing a great job of triaging the bug. So hopefully this will get noticed very soon. Okay, I have filled in the content, the body for the Jira issue, and the environment where this thing occurs, this bug occurs. I've referenced our CI failure here and referenced the project where this issue manifests. And now I'm going to create the ticket. I'm going to assign it to myself since I'm going to make the pull request immediately after. And yeah, let's do the pull request. Again, I guess I can go here now. Uh-oh. Okay, now GitHub is suggesting we can make the pull request. That's good. We're able to merge. I'm going to create the pull request and reference our bug report, SR6647, right? And hopefully this will get reviewed. Another thing that can happen is someone will run the integration test for us on Linux, which would be great. In fact, I happen to be a collaborator, so I can do that myself. But as a normal process, though, we should wait. Okay, let's see what happens next. Gaze at the CI. Look at it. Okay, so in less than 24 hours since we submitted the pull request, we've already gotten feedback, and looks like the reviewer liked our changes, except our variable names need some improvement. I think I personally agree. So we have some pretty wacky names here. And we can change it. Let's see exactly what they're saying. So though maybe the variable names around this point, not just the ones you're adding, the existing ones as well, could stand to be a little clear. Okay, so looks like we have free reign to improve the variable name around our code. So here it is. Here is our code. Let's think of a set of better variable names. This is another set of contribution we can do. So how about we name this this guy? Well, interestingly though, this is used in more than one places. Okay, I'm just gonna change our own method here. Okay, so keep the change local. All right. So let's change this name to maybe cursor. Cur pause. All right. Last component start position, start of last component. I would say this is a good name and is actually not that much longer than this anyways, right? Okay, so let's do that as well. Start of last pass component. Yeah, that's not worse. Again, this looks really funny to me. Maybe we can format it slightly. So we have else if this, we have this, we have this, we have this, and let's move this to a new line. That looks much better already. I'm gonna delete, well, the tricky part about contributing to code base that you don't normally contribute is that you can't just go in and change everything. I mean, that is a form of contribution, but I think that does more disruption, well, a certain amount of disruption as well. So we have changed cursor. We have some four English words for start of LastPass component. Now we have previous pose. Let's just change it, right? Previous pose, it means previous position. So I'll just do the same thing. Select the function body, pre-pose, previous position. Yeah. And pre-pose, our own creation here can maybe be better. So this is the previous position to the previous position. So we can call it like previous to position. Previous, what's a good name? Previous two positions. Two position back. Even more previous positions. Yeah, previous two positions sounds good. So we're setting pose to previous two positions. Previous two position. Okay. Now let's look at this function. We can even rename chart maybe like a character or something. There. Okay, so this now reads more like a function that I would write in the first place. But the problem now is it's very different in the naming style to the other functions. I guess that's okay. I want to limit the change set to this local area. So let's just do that, and then I want to also make sure we still compile. I'm going to run the whole test, and oh yeah, I need to switch to the latest development snapshot. I don't remember showing that previously, but it is, if you want to develop with Xcode for Swift, you always use the latest snapshot. So this doesn't seem like things relate to us. Okay. So after cleaning and rebuilding, we have built it, and now we're building the test target. And I'll declare victory as soon as this compile finishes, which there's no reason not to because we didn't change anything in the test, right? Okay. Test foundation, almost there. And obviously, an easy way to contribute to the Swift project is, first of all, Foundation is super easy to contribute to because it's just pure Swift, like you've seen. And second of all, if you don't know where to start, come fix these warnings. Like this should be fairly easy to fix, right? Things like renaming, like you can literally take the hint here and just make sure that you didn't break any tests, right? Cool. So we are running the test. Since there's no functional changes, I'm gonna assume that that's good enough. Improve local variable names, and then push it to our branch. I just realized that one of the variable name is not what we thought it was. This guy, I think the original one is current position. So CUR actually means current. Yeah, let's rename that again. Current, cursor current position. Okay. Whoops. Oh, it passed. That means, yay! Okay, so after issued please test and merge, well, again, this will come from some other committers if you don't have commit message access, but we passed the test, and now our pull request is merged. All right. Cool. So yeah, there you have it, folks. That's how you fix a bug in Core Foundation. No, sorry, Core Libs Foundation. Open source. If you like that, please consider subscribing to my channel. It will help me greatly. Thank you very much.